Hello to everyone. I am Roberto Verdecchia. I'm going to present a research I conducted jointly with Philippe Kruchten, Patricia Lago, and Ivano Malavolta. The research is titled Building and Evaluating a Theory of Architectural Technical Debt in Software-Intensive Systems. Just to provide you a brief idea of what architectural technical debt is, you can say it's a set of architectural design and implementation choices, such as choices regarding the structure of a software system, the technology used, the languages the system is implemented in, and so on and so forth. These choices are made early for expediency, but are preventing further development today. To put it in simpler words, it's the stuff that is very hard to change now while hurting us a lot. The goal of our study was to understand how practitioners conceptualize architectural technical debt. What are the essential concepts, and what's the relation between these concepts? In order to achieve our goal, we carried out a mixed method empirical study. In the first phase, we conducted a Brazilian grounded theory, and then we presented the emerging theory to industrial practitioners via focus groups in order to evaluate and refine our theory. This led us to formulate a theory of architectural technical debt, which synthesizes the recurrent themes into 9 core categories and 63 concepts and the relations between these concepts and categories. At the core of our theory lies architectural technical debt items. So how does architectural technical debt manifest itself in practice? Throughout the paper we made extensive use of quotes in order to provide the reader further examples and knowledge on how we achieved our findings. Another category of our theory are the causes. So what causes architectural technical debt? Here we see some prominent examples such as time pressure or simply the passing of time. Then we have consequences. What are the consequences if architectural technical debt is left unmanaged? We see carrying cost, higher risk exposure, or even completely crystallized architectures. Then we have the symptoms, which rather than being architectural technical debt items per se, symptoms can point to the presence of architectural technical debt items in a software system, especially if more symptoms co-occur. Then we have the management strategies. So how are architectural technical debt items managed in practice? Of course, people also play a key role in the development and maintenance of a software-intensive system. So people is also a category which emerged in our theory. And also people communicate between each other concepts related to architectural technical debt. Finally, our last category are the prioritization strategies, which in our theory do not follow an established methodology, but rather rely on the gut feeling of software developers and managers. This concludes my presentation. Thank you for your attention and take care.